I used to have just reminder about our quiz next Sunday, right? To be about chapter 5. Try to practice the ideas that we have done. Today, inshallah, we finish chapter 5 and we'll give a review, quick review of the most important ideas about this chapter. So last time we started talking about linear transformation of Gaussian random variables. We finished already the transformation of multi-random variables. So we have multiple inputs or two random variables at the input, and we have certain transformation and two random variables at the output. And we found out that the PDF of the joint PDF of the output random variables, y1 and y2, for example, will be equal to the PDF of the input random variables, where basically the x1 is equal to the t inverse, which is the first inverse function. X2 would be the second inverse function, multiplied by the absolute value of the function. And we define the Determinant as the matrix that contains the derivative of the inverse derivative of the first inverse function is 51, and so on. And then we gave an example about multiple random variables linear transformation, and we found that the PDF looks like this. And then we started the linear transformation of Gaussian random variables, and we said that Gaussian random variables are especially important to us because they appear in many places, especially when we talk about Gaussian random processes, as we will come inshallah in chapter 6. So we stopped here, where basically the final result was that if I have, I will focus on the result of two random variables. So if I have y1 equals a11 x1 plus a12 x2, and y2 is equal to a21 x1 and plus a22 x2, then we are interested in the mean, so y will be certain transformation matrix multiplied by x, and x is the inverse transformation multiplied by y. These are vector notation. And of course, for this to happen, t should be non-singular. Non-singular means that it's a vector. And in this case, the mean of y will be equal to the transformation matrix multiplied by the mean of x, equals side. And the covariance matrix of y will be the transformation matrix multiplied by the covariance matrix of x multiplied by the transformation matrix transpose. And as I mentioned, we said that we will not derive this, and just leave it for you to read it if you are interested. So it's considered as a self-study. The derivation, however, the final answers are not self-study. They are included. So let's take an example. Today we'll take an example and we'll take another example, and then we'll go over a very quick review on the most important ideas in chapter. So we have here the question on that we are interested in. We have basically x1 and x2 are zero mean Gaussian random variables with certain variances. So I gave you that x1 and x2 are Gaussian random variables with zero mean, both of them, and the variances are given. And the covariance between x1 and x2 is given. So first of all, x1 and x2 are they independent? No, why? When covariance is not true, are they uncorrelated? Why? If they are not uncorrelated, they are not independent. Okay. And then we defined two new random variables, y1 equals x1 plus minus 2x2, and y2 equals 3x1. So if from here we can find the transformation matrix to be equal to 1, minus 2, 3, and 4. Okay. So we basically take the elements of x1, next to x1 and x2, and put them in transformation matrix. In this case, and of course, given the information that we have, we know the covariance matrix of x. Here's the covariance matrix about عن الvariance of x والvariance of y and the covariance in the of the نتذكر ايش كانت الcovariance matrix of x؟ الcovariance matrix عبارة عن ايش؟ expected value of x1 minus x1 mean. multiplied by itself, so which is basically square, right? And we have the covariance of x1, x2, and we have the covariance of x1, x2, and we have expected value of x2 minus x2 by square, which is the base. We have done this before. Then now, and of course we know that since y1 equal this in terms of x1 and x2, then what is the mean of y1? How do you find the average? Yeah, well, again, what is the mean of y1? The balance were examined, and you need to, these are ABC compared to chapter 5. These are chapter 4, chapter 3. So what is the mean of y1? Yeah? Yeah, how did we do this? Simply by, what is y1? All this. We go back to the definition, right? What is y1? x1 minus x2. And as your friend mentioned, because this is linear, we can write this as expected. I'm going through the details because I want you to know how to go over the details. And then, what is the expected value of x1? It's 0. I gave you it's 0 minus 2 multiplied by, what is this? Another 0. So we have basically big 0. So we know, and of course you can see that since, without going through this, you can see that since y equal the summation of two values that are both 0, then what is the mean of y? What it is. Okay. Similarly, what is the mean of y2? Because this is 0, x1 has a mean of 0, and x2 has a mean of 0. So we know now that both of them are Gaussian with 0 mean. Y1 and y2 are Gaussian with 0. Now the remaining is to get the covariance matrix of y. And we know from the derivation that we did not do, although I gave you the final answer, it's equal to the transformation matrix multiplied by the covariance matrix of x1, x2, multiplied by the transformation matrix transpose. We just put the transformation matrix, covariance matrix, and the transpose of transformation matrix, and we do matrix multiplication, we get exactly this. You know how to do matrix multiplication, right? So now from here, what do we get as information? What do you read from here? This is the covariance matrix of y1, y2. What do you get out of this? Give me some information that you read from this covariance matrix. Yeah, follow. What is the variance of y2? This one is the variance of y2. What about the variance of y1? 28. And let's see how something yeah, so what is this? Minus what? 66. What do you call it in English? Covariance. Okay, covariance. So we know now that we have a variance of y1 is 28, variance of y2 is 252, and the covariance between y1 and y2 is minus 66. So how can you what can you describe? How can you describe the relationship between y1 and y2? كيف علاقتهم ببعض؟ طردية عكسية independent عكسية صح؟ It's extremely from the negative side. Okay? Now we know this, and because we know all these things, we can write the correlation factor, which is the correlation coefficient, which is the covariance divided by the standard deviation of y1 and y2. And doing this, we will see that it's basically equal to minus 0.7. Okay. So now from here, we can see that at the beginning, we started with the correlated random variables. Okay. And by this transformation, we ended the one also correlated. However, the correlation is negative, right? This was the correlation equal or positive. With this transformation, we transform the two correlated random values into a positive correlation to negative correlation. If we started with zero correlation and correlate, if we didn't have zero correlation, then it will look like this. Again, correlation will be also okay. Now, knowing all this information, can we write the PDF of Y1, Y2? Do you need more information than what you have? We don't need. We have the means, both of them are zero. So we have, these are Y1 minus Y. This is the mean vector, and this is the mean vector, and this is the inverse of the covariance matrix. So just putting them together, and you will find this. Okay. So now, if we just would like to see how it looks like, so it will be 2 pi. I will not go through the. So this will be the determinant. Just leave it here. Okay. You record. It will be basically something like 1 over 2 pi. You need to find the determinant, so I will not find it. You can just, this is square root. And then e to minus, yes. What is the first one? y1. خلينا ناخذ نشيل الفيكتور نوتيشن. y1 تمام minus 0, so it's y1. So nothing to subtract y1 squared, صح? Divide by what? 2. Divide by what? It's usually minus half. Multiplied by y1 squared, divide by the variance of y1. What is the variance of y1? 28, right? And then plus y2 squared, right? 0 mean, divide by the variance of y2. What is your variance? 252. And what do we have also? The intermediate term. ايش تذكرون intermediate term كيف كان شكله؟ لا intermediate term that is connecting that connect the y1 and y2 was function of rho. Yes. What was it? أحد يتذكر؟ No. Variance. So rho multiplied by variance x, which is 28, multiplied by 252, and then divide by. Yeah, ما في حد عنده نوت؟ Doesn't like this. هذه كانت الجوينت ليجاشن نتذكروها. We started with this joint ligation. And you say that when rho equals 0, هذه 2 minus 2 rho x minus x bar y minus y bar divided by sigma. Okay. So now we can have. Yeah, we need to know these things. So now we have what? Rho y1 2 rho, sorry. y1 y2 divided by sigma x. What is sigma x? Yeah, square root of 28 multiplied by square root of kam? 252. And this is the PDF, the joint PDF of x and y. Okay? So the y1 is 1. So now if I give you any of these with, for example, 2 random variables and I give you the transformation matrix, you should be able to find. So you have أي سؤال?
What about this formula?
This is the vector formula. The vector, usually we use it when you have more than 2. However, you can use this, and if you put here CXY, which is CY, which is the covariance matrix, and you open it, basically this is transpose multiplied by covariance matrix inverse, you need to find it. And if you open it up, you will get this. Right. Okay. Now another example, two random variables, not necessarily Gaussian, any two random variables, x and y, where I give you the mean of x and y, I give you the variances again, and I gave you the correlation coefficients. Now we have two new random variables, b and w. B is defined as this, and w is defined as this. Okay? Now the question is, for v and w, find the means, the variances, the correlation, and the correlation. Start with the mean, please. Now, exam will be all like this. To find out. So you need to do many practice questions. زي ما قلنا كل اللي جاي الآن من chapter 6 and 8 will depend on chapter 5. Two random values or more, understanding of the correlation, covariance, independence, function of random values, efficiency. So you need to master these things very well. Right, start with the means. Now, طيب, so how did we do it? Let's see. Basically, we have the means and we have the variances. So I'm listing here all the given. Then the mean of B will be equal to the mean expected value of B, and we, as we agreed before, we just substitute the VS, and using the linearity, it will be minus x bar plus 2y bar, and this is all given, so we have. Okay. Similarly, for W, expected value of W, again we substitute what W is, and then we separate them because of the linearity, and we integrate. Good. Now, the next one, the variances of W and of V. We always go back to definition. Always go back to the definition. Nothing magic. ما في شيء لازم تتذكره. Go back to the definition and start from there. Any answer? Any answer? There should be variance of 3, 12. What? Variance of 3, 12. 12? And the variance of W? No, please try to say to us. طيب يا شباب, let's see. Start with variance of V. How do we find it? We go with variance of V, which is expected value, V minus V bar. And we just write what V is. So V is minus X plus 2W. And we know V bar is minus X bar minus 2W1, right? And then we open the square. We basically collect the X with X bar and the Y with Y bar. So we have here minus X bar plus 2Y minus Y bar all square. Okay. So now, how do you find this? We square the first plus square the second plus 2. We open the square, right? So square the first is what? We give the expected value of minus X bar all square. What is this equal to? The variance of X. So this is the first item. Plus, we have the second item, which is 2. We have 2. We have basically 2 Y minus Y bar squared. So under this expected value, what is this equal to? 4. What? The variance of 4 multiplied by the variance of 1. And we have the cross terms, which is minus 2 multiplied by 2 multiplied by X minus X bar, Y minus Y bar under expected value. So what do we have here? We have minus 2 by 2, which is minus 4. X minus X bar, Y minus Y bar, which is the expected value. What do we call this? Covariance between X and X. Between X and Y. So we have here the variance of X minus plus 4 the variance of Y minus 4 the covariance of X.
So the of V minus V minus 3 definitely
3 which is the mean. طبعا yeah, indeed طبعا. لكن it will not help you much because you will end up with terms that are يعني خلينا نقول حتصير اطول. هنا احنا we collected things such that we ended up with the variances. لكن if you put 3 and you open up, you will end up with expected value of X squared, expected value of Y squared, which is we have them already, but it's a different way. لكن ما اخر شيء المفروض يطلع لك نفس النتيجة. So we have here the variance of V equals this, and we know all of them. So if we substitute, what do we get? Yeah, do we know the variance of X? Can we solve variance of X? 4. What is the variance of Y? W. However, do we know the covariance of X? Y. Do we know? We know the correlation coefficient. So what is the addition of here? Correlation coefficient equals the covariance divided by sigma X sigma Y. So we know we want the covariance, and we have the correlation factor. We have the variance, sorry, the standard deviation. So we find the covariance matrix, the covariance between them, which is 0.4 multiplied by sigma X sigma Y, which will be 0.8. Now substituting, sigma V squared will be 4. أحد يرسم؟ تمام؟ يعني نقول شوية لكن this is it. Any question? Now similarly, you can do or find sigma W squared. So the sigma W, yeah, which is the variance of W, by following similar notation. And you end up with this equal to sigma X squared plus 9 sigma Y squared plus 6 covariance XY, and when you put them together, it will be 17. That's the problem. أي سؤال يا شباب؟ طيب الآن how to find the correlation between X and Y, between V and W. So try to find the correlation. What is the correlation? What is the definition of correlation? Expected value of V and W. Yeah. Similarly, start with the definition and then substitute for V and W and simplify. راح نسويها في الجلسة. Nothing much. So what do we do? In order to find the correlation, what do we do? We start, as we mentioned, by the definition. Correlation of VW, which is the, by definition, V and W. Now we substitute for V and we substitute for W. And then we open up. When we open up, we try to collect similar terms. So we have here what? Minus x multiplied by x with the expected value. It's minus x bar, x squared bar, which is minus expected value of x squared. And we have what? Minus x multiplied by 3y, sorry, plus 2 multiplied by 2y multiplied by x. So what do you have in total? Minus xy bar, which is expected value of xy. And then we have 2y multiplied by 3y, which is 6 expected value of y. Do we have the first one? Expected value of x squared. Do we have it? How to find it? We have the variance, right? And we have the mean. So what is this equal to this one? Yeah. The mean plus the variance. The variance can come 4. So we mean 1. So basically 5 plus 1, 4 plus 1 will give you 5. The mean squared is the variance plus the mean squared, right? So what was the mean? The mean كان 1 والvariance كان 4. So 4 زائد 1 squared is 5. And what do we have? What about the variance? What is the expected value of y squared? The variance of y plus the mean of y squared. What is the variance of y? 1 plus 2 squared, which is again 5. So we have again another 5 here. And what is the expected value of xy? Correlation, how to find it? You have information about it. تمام. عندنا coefficient، لكن ايش علاقتهم ببعض؟ Expected value of xy، sorry، xy، وايش علاقتها بالcovariance؟ بالcorrelation، sorry. تمام. هذه الcorrelation، ايش علاقتها بالcovariance؟ Yeah, we know this. فاحنا عندنا هذا. We have this now, صح؟ We already calculated. ايش علاقة الcovariance مع الcorrelation؟ هتذكروا علاقة؟ Correlation minus x value x minus x bar y bar equals the covariance. صح؟ We have done it again before. We start with the definition and we open up the square, the parentheses, we need up with this. So do I have this? Expected value of y, x, I have it. I have expected value of y. I have the covariance from here. We already calculated it. So I have this. What is this? What is this equal to? Rx. Y. What do we call? What is it equal to now? كم هذا حصلنا عنه؟ 0.8 صح؟ And what is this? 2. So basically 0.8 plus 2, it's كم؟ 2.8 تطلع? So now we have basically, and basically we have it here. Yeah, it's cxy plus x bar y bar, and we end up with 22.2 as the correlation between V and V. Okay. Now, what is the correlation between V and W? Correlation factor, correlation coefficient. It's equal to the covariance of V and W divided by sigma V sigma W. Do we have the covariance of V and W? We don't. But the case is under correlation, under it means. Right? So we can just plug them here, divide by sigma V sigma W. We calculated them already, and we end up with 0.129. ايش هيكون؟ Who is more correlated? X and Y or V and W? كم كان correlation factor between X and Y? 0.4, and here 0.13, which pair have more correlation? علاقتهم بعض أقوى. So clearly the transformation reduced the correlation. Okay? Do you have any question? This is a critical question that we need to be able to solve. Now, going back to the previous question, jointly Gaussian. Now, if I tell you, if I ask you one more question here, now already we found a covariance of y, we found the correlation coefficient, and so on. If I ask you one more question, and we found the PDF, the joint PDF. If I tell you what is the PDF of angle W, which is equal to y1 plus y2. And I ask you what is the PDF of this. Can you find it for me? Asha, how do you do it? Convolution, huh? You can start with convolution, but you end up with extremely complicated. Let's again, integrals. What is W1 and what is Y1 and Y2? Not only Gaussian, they are jointly Gaussian. And we know because they are jointly Gaussian, any linear transformation will give you Gaussian. So these are two jointly. These are two jointly Gaussian. Why they are jointly Gaussian? Because the original X and X1 and Y1 are jointly Gaussian. And because of that, this is Gaussian. Any linear, we established this before. Any linear transformation jointly Gaussian will give you a Gaussian. If I ask you, what is the PDF of Y1 given Y2? What will the answer be? Also Gaussian. You need only to find the mean and the variance. Here, you know, because it's Gaussian, you need to find what? Find the PDF. What do you need to find? The mean of the variance. If you find the mean of W and the variance of W, it's fine. You have the Gaussian distribution. You can write it. Right? So what is the mean of W here? Because it's Gaussian, we need to find the mean of W. What is the mean of W? Mean of Y, 1. So Y1 bar plus Y2 bar, which is equal to 0. So we know that W is a Gaussian with 0 mean. So the only missing is variance W squared. هذا السؤال ما له علاقة بالسؤال اللي فيه. So W variance W squared, what is this equal to? Expected value, we always go with the definition, W minus W squared, right? Well, so in order to find this, you need to write down the variance. Basically, you need to write W as Y1 minus Y2 and W bar as m equal to 0. So this is equal to expected value of W squared. Right? But what is expected value of W squared? What is W squared? Y1, sorry, Y1 plus Y2 whole square. Y1 plus Y2 whole square. But what is this equal to? Open up the view. So what do we have? Y1 square plus Y2 square. هذه معناها expected value, huh? Plus what? 2 Y1 Y2 expected value. Do we know this? هذا ايش؟ هذا correlation صح؟ What is the correlation? ايش كان correlation بينهم؟ Did we find the correlation? Yeah, it's equal to minus 66. Why is it equal to minus 66? Correlation عبارة عن covariance minus plus the two means, right? But what are the means? Zeros, right? So the correlation equals minus 66. So we have here what? We have the variance of Y1, we found it before. Come. 28. We have the variance of Y2, which is 252. And we have the correlation, which is minus 2 multiplied by 66. And you can write this, you will find the number. Now you have the variance, you have the mean. Yeah. It's plus, however, we have minus. Yeah, so it's plus over 2 multiplied by minus 66. Alright? Will be 148. So now we have the variance, we have the mean, we can write the Gaussian solution. You can write now from here, you can write FW equals, you know. Okay, Shabab? So the important thing that you need to know, or at least reminded of, if you have jointly Gaussian and you add all linear transformation, you also have a jointly Gaussian. Don't go into convolution and this full exam solution. You end up with that. Well, so always utilize the properties of the jointly Gaussian. Now, if I ask you, what is the PDF of x1 given x2? Because they are jointly Gaussian, x1 given x2 is also jointly Gaussian. Is also Gaussian. And you need only to find the mean of x1 given x2 and the variance of x1 given x2. Okay? Or any other such questions? لا الجاوسن you need to know الجوينت جاوسن هذه you need to know هذا الأشياء مهمة جدا لكن الشيء الثاني طويل لا يعني مثلا الماتريكس هذه احنا قلنا الماتريكس ما لها احنا تكلمنا الأول إنه we only deal with 2 by 2 so anything 2 by 2 you need to know otherwise يعني مثلا جوكيبيان تكلمنا عنها you need to know how to find the Jacobian for 2 by 2 if you have any function. Okay? طيب, let me go very quickly over what we did in chapter 5, at least highlighting the main ideas and information before we go into chapter 6. Well, luckily, we have also the review of chapter 3. So نتذكر chapter 3 can expected value with moments and the central moments, and we talked about why these equations are true because we explained their meaning, the physical meaning. So you need to be able to find for any PDF, the state or continuous, you need to find the mean, the variance, the expected value of any moment, the central moment of any type for discrete and continuous. And we talked about the characteristic function and how to use it to find the moments, right? By differentiation. And if we have a function of random variable, whether monotonic or non-monotonic, you need to be able to find the PDF using these equations. And this is only if you have a function, single random variable, a function of single random variable. So y equals t of x. However, when you have y equal t of x1, x2, then you use the equation that we did in chapter 4. And then we talked about the expected value when we have a function of random variable. You either have it, you either need to find the PDF of this function, or you just plug in whatever that function next to the PDF, whether continuous or discrete, and find the corresponding the corresponding number. And we talked about the sum of functions. If we have a function that is a weighted sum of random variables, then the expected value of this sum will be equal to the weighted sum of the individual expected value. We talked also about the joint moments. طبعا بعضها ما له خلينا نقول physical meaning. However, we only focus on these for the physical meaning. So we talked about a mean and the two means, and what we called as the correlation. Correlation has a meaning. We talked about the meaning, what is meaning, and so on. And when two random values are orthogonal, when they are independent, when they are uncorrelated, ايش علاقة correlated independence with orthogonality. And we talked about also some examples here of orthogonal maths, and then the linear transformation. Okay. And then we talked about central moments, and we also focused on the most important central moments, which are the variances and the covariance. Covariance اللي هي expected value of x minus x bar, y minus y bar. وإيش علاقتها بال correlation? So the covariance equal the correlation minus the productive difference. And uncorrelated means that the correlation equals the product of the means. So if they are uncorrelated, then the covariance will be. And then we talked about the correlation coefficient. What does it mean? So we now assign. We said that we would like to measure how the العلاقة between two random variables such that we have a normalized factor from -1 to 1. -1 means that x and -1 are highly correlated. 1 or close 1 means that x and y are highly correlated, and around 0 means that x and y are uncorrelated. And we tried to plot the scatter plot. What does it mean? كيف شكل scatter plot? How does it reflect? As you have more trend, stronger trend means you have higher correlation. The more clear the trend, the higher the correlation. And then we talked about this is very important. We find that the expected value of a weighted sum equals the weighted sum of the expected values. Similarly, if you have a weighted sum of random variables, then the variance of the resulting random variable equals the weighted sum of the covariances, which is equal to, if you have uncorrelated, it will be equal to the weighted sum of the variances. If they are uncorrelated. If they are not uncorrelated, it will be double summation of the covariances. And we talked about the joint characteristic function and how to use it to find the joint moments by double differentiation. And then we came to the most important part, which is the joint Gaussian. The PDF كيف شكلها, the individual PDFs, and if they are independent, if they are uncorrelated, means that this becomes 0, the middle term, which makes the PDF can be resolved into product of two PDFs. And this established the fact that if you have uncorrelated joint Gaussian, they are independent. And we show you how the joint PDF looks like, and we talked about the contour of the locus, where basically you fix the PDF. And of course, when we define the covariance matrix, the inverse of that, and in some examples here. Yeah, how to create uncorrelated random values, uncorrelated random values by using some linear transformation with certain theta, and what theta will be. So you don't need to memorize this theta, you need to be able to find out this. And these are the properties that will help you simplify problems. Yeah, مثلا هنا, if you have if you know the first moments and second moments, then you know everything about it. You don't need anything else. So if I ask you to write the PDF, you should be able to write the PDF if you know these. Uncorrelated means statistically invariant. They are joint Gaussian. Linear transformation of joint Gaussian is also Gaussian. Have a contribution. Finding the PDF. And the marginal density is also Gaussian. So if I have joint Gaussian, then every one of them will be Gaussian, as well as the conditional density. If I have two Gaussian, then one of them conditional will be also Gaussian. And مهمة properties because it simplifies your life. And we gave several examples here, and then we started talking about the transformation of when you have, first of all, single function or multiple function. Multiple function, and we went through some examples. And when you have single function, simply you need to find first the CDF using the definition, and then find the region at which you need to integrate between two. And we gave two examples here. And in the exam, you expect similar examples. An example of this sort. At least to give you the idea of how to solve it. And we ended up with linear multiple transformation where the Jacobian is defined, the Jacobian matrix, the determinant, and how to find the PDF of Y, joint PDF of the output as a function of the joint PDF of the input. And then the linear transformation as an example. And then we focused on the Gaussian, joint Gaussian. And that's it. Even have chapter 3 and chapter 4. Chapter 4 can go PDF, joint PDF, joint CDF. Thanks, man. Can you do this, please? And make sure that it's studying well and keep sure it has the name of that mama. If you have any questions, you can go. You need more help, you can go. That's in sure. I lost you somewhere in between chapter 4 and 5. شكلي مشيت بسرعة ما أول كنا مضغوطين أول حاجة مشيت بسرعة ما حسيت كده في ايسوليشن. دخلنا فترة البروجكت انشغلت زيادة. فيبغاكم في البداية يعني try to give some time. الماتيريالز تتراكم تصير أصعب وأصعب. كل ما نمشي زيادة أنتم تلاحظوا عليه. فميك شور إشباهكم cover الماتيريالز so the example راح this is يعني basically only 1 week from now. Thank you very much, and we'll see you Thursday.